So today we're going to talk about a little bit of the basics of laying out your channel geometry before you would export that into a HEC RAS file. And let's see. One thing to note is there are so many ways. I've put a lot of reference material. There are so many ways to build a HEC RAS model. So many different programs do the same thing, like GeoPack had some options. Now you can do it in ORD. Heck, GeoRAS had a way to do something similar to what we're going to do this week. And I know that Tamara has played, and I've played a little bit with inside RAS itself now, and RAS Mapper in the latest versions. You can upload directly your surface file and basically build a model, build a geometry from scratch there. So each method you may have to tinker with to get it to work. I think some of the directions that you draw things might be reversed in one or the other. I'm going to stick with this one I'm working on right now. I'm doing it in ORD, so I'll go that route and show you. But the concept is the same. Ivy says GeoPack HEC RAS doesn't work anymore. Okay. Yeah, I'm sure we won't have to use that one anymore, hopefully then. And there's also like tools that we haven't used, like that Civil Geo, I imagine does a really similar process as what all these do. So I want to start off by introducing some terminology that I think will get y'all a long ways, just to be able to, when you're talking with your project managers in Roadway or even the client, almost every time we get a project for a roadway, we're going to do almost the exact same thing, where we might have a model already, but when we get that, so that would be whether it's FEMA or not, we'd consider that if it is FEMA, then it really is the effective model. But if it's not, if it's just some other model that the last, maybe like this project that I'm doing today was inherited from an overall schematic that Brown and Gay did. So it becomes a quote effective model. And then we always take that and verify it, and we produce what we call our corrected effective model, which is just us correcting the whatever we're giving, verifying it, seeing if it matches up with topo, and then that corrected effective is what's going to be the baseline for our project. So we do these HEC RAS models basically to make sure we're not increasing the water surface elevation more than is allowed, and in most cases, in a lot of cases, we're just trying to hold it to zero. Some areas let you get away with up to a foot of an increase in the 100-year water surface elevations, but a lot of times we try to just design to where we're not having any impact at all. So today, if you looked at the syllabus, we're going to be talking about laying out your channel and your bank lines and your flow lines, flow paths. And I'll start with just opening up HEC RAS and showing you what those elements are. So this is, and we're going to get into some more HEC RAS modeling this week. So I'm not just jumping ahead, I'm just showing you in here what it looks like. So your channel is going to be your stream center line, and that is just that we need to draw the stream into the file to export into the geometry. HEC RAS uses that to generate stationing. So stationing in HEC RAS increases from downstream to upstream. So it's this is the downstream end of the model, and the stations are increasing going this way.
Let's say you're trying to show us anything, because we see your pretty face talking, but we don't see anything else.
Good point, Jonathan. Y'all don't see my screen? Okay.
Eric's face is a trademark of JMT Corporation.
So the streamline is going to be this blue line here, and it's just going to be the center line of whatever creek or channel you are modeling. And the other two items we're talking about today is your bank lines, which you see these little red dots here. That's your banks. And in the cross-section view, that is these red dots here. So that's meant to be your channel banks, the top of bank of your channel. You just want to be kind of close. It doesn't really matter that it's, we're looking at really irregular cross sections. So if I were doing this manually, I might choose here, but it doesn't affect calculations per se, other than a lot of times the Manning's N values will be entered using this option here. And I'm using a blank geometric file, which is, let me go to the actual one. Still wrong. So a lot of times they're used to conveniently input changes of Manning's N value, but they don't have to be as well. You can also input as many Manning's N changes as you want through a section, but skipping ahead of myself. But anyway, that is your bank lines. It's basically meant to be where the channel bank is. And the other item that we're going to be drawing today is your flow paths, and you don't see that anywhere, but with these tools that are used to build the model, what the flow paths do is generate your left of bank reach links and your right of bank reach links, which are right here. So with that, I will open up my MicroStation file.
Eric, can you please minimize that box?
This box?
Yes.
Yes.
Thank you. All right, now you can see all your stuff.
Okay. For this project, I'm going to start at a point where a lot of projects will start for us. We had a model, and so that was previously done by another consultant. So we're going through the steps of verifying their model. So we do have cross sections and a streamline generated from them. In the email I sent about the FEMA base level engineering, in some of that PDF, I describe how you can export that to shape files. So I have exported their cross sections and their streamline to a shape file. And that's why I have that in the model. So if you're building a model from scratch, cross sections are after today's steps, after the steps we're going to do today. So first we want to draw in our channel. So what we have here, we have a creek. I've got the channel line that I've taken from Brown and Gay's model and have it in my DGN. But in order to create a model, which to do the steps for generating that geometry, we're going to start with drawing in an alignment for the center line of the channel. So I'm going to do complex geometry, complex by PI. And this is where things might get a little different. Let me start by showing some of the resources. The HEC RAS user manual is excellent. I think it describes a lot of the things that you do for creating one. We don't really, I haven't used HEC RAS in a while, but it's very similar to what the way you do it in ORD, and it just gives a lot of helpful descriptions. I think it might be too close. I think it might tell you to draw the stream the other way from which the way you do it in ORD, like from upstream to downstream. But in ORD, you draw it from your downstream and then go upstream. So there's this, and then where else? There's not really that many helpful resources on stream center line because it's just so easy. It's just your stream. So we're just going to start. I'm going to start with this and basically draw over this channel line here. Generally, we're going to get, if we, we're going to get a model, and what we're concerned about is upstream and downstream of where our project is. Generally about 5 or 6 cross sections or more, but sometimes we'll get this really, really long model, in which case we need to look for our corrected effective. We need to look more carefully at what's immediately surrounding, and we can care less about the stuff that's way downstream of us and way upstream of us. And we're going to try to make our modeling tie into those water surface elevations upstream without any increases anyway. So this model was made specifically for this crossing, so it's about the same extents as I'm wanting to look at. I'm going to turn off this shape. So if I was doing this model from scratch, the only difference was I would just be figuring out straight from the contours. Fortunately, they did a pretty good job of placing their center line, so I'm able to just blindly follow this to them for the most part. I could technically end it here. I'm just going to take it all the way up for where the current cross sections go. In case I ever want to add cross sections to this model, I'm just going to take it all the way up to where it ends. because it's not that much farther. And that is the streamline. And then the next parts have a little bit of rules to them. Actually, this next part doesn't really. The next part is the bank lines, drawing those in. I've made some levels. I think it's a good idea to have levels describing what things are. So if I didn't emphasize it enough, HEC RAS, you are, I don't think I mentioned this yet, but I will be reiterating this over and over. But in HEC RAS, you consider your directions looking downstream. So we drew that in going upstream, but as far as what's left and what's right, I'm gonna always imagine myself looking downstream on this channel. So this is my left and this is my right, even though that's backwards as what is real left and real right, the way we have the view. But hopefully I'm just used to thinking that way, but and you will be too after a few of these, but you just, whatever you're looking downstream, whatever your left would be then, that's your left. So this is my right bank, and I've got it on a special level. It doesn't really have to be as far as creating the model, but I think it's just helpful for seeing what things are. So for that, I'm just going to look at the contours, see where the bank approximately is. Doesn't have to be perfect. And I'm just going to draw in the banks. And since I got about 5 minutes left on this jam session of boot camp, I'm just going to draw that short piece in. On Friday, we're all going to run through this exercise and create our own model or create our own geometry. So this is the right bank. And lastly, the last part of today's session is the overbanks. So for that, this is something that I went through and found the resource for y'all, so you don't have to take me at my word. I'm one of those things I just say and say just because, but it's somewhere on your flowpath lines. This is from the HEC RAS Mappers Users Manual. Lines will be created in the overbank areas on a 1/3 distance from the bank stations to the end of the cross section. What your reach links are supposed to be based on technically, just so you'll have the knowledge, is the center of mass of your floodplain in that overbank area. So you've got your channel line. This channel line is going to be used to compute the main channel length once we create a geometry. Your overbank, it says 1/3 of the way of your cross sections. Well, I could have drawn these cross sections and as long as I want, but it's assuming your cross sections, and it doesn't have to be perfect. So you're gonna get a different answer every time you do it, but it's gonna be approximately the same. So a lot of times what's helpful is you will have the floodplain. And so that really, you could take your 100-year and you could go 1/3 of the way across the floodplain or 1/3 of the way across how long you drew the cross sections, guessing that the floodplain would be. So keep that in mind when you're doing cross section. When it says that 1/3, it's assuming that's what you're guessing the floodplain will be. So we want to be generally somewhere about 1/3 of the way out here. And again, it's just to get some length that the model can do. It's not something anyone's going to go back and critique and say, oh, you did this wrong. Your flow path is 1/2 the way instead of 1/3. It's just, you want to try to do it as following the rules, but you're never going to do it again once you get it. So I'm going to draw some flow paths in somewhere about here. This is for my, what side is this for? If this is going downstream.
You're right.
Anyone? You're right. Yes, that's correct. So I would just kind of shape this with the contours, and it's just an arc, and with your stream, and you just kind of fly through here. One thing, so usually if you're doing these directions straight from scratch and building a model from scratch, these steps are done before you do a cross-section line. Since I'm taking someone else's model and kind of verifying it, maybe make some tweaks to it, I already have some cross-section lines. So one of the rules is I want to make sure the cross-section lines do not cross any of these lines we're drawing today, the channel, flow path, banks, more than once. So that's one thing to be careful that I'm not coming up here doing it, crossing it 3 times. That'll give you some errors when you try to run things. So I'm just gonna try to not do what I said not to do and go up that way. And it's not helpful that I cheated and didn't go all the way through the other one. I also don't want this to cross my bank line. So, but I'm gonna go ahead and take this one all the way up. And we would do the same thing for the other overbank over here. But I'm going to try to hold to these time slots that I've gotten, that I've set aside for this. Did all that make sense today? Does everyone feel like they could draw in the channel lines and bank lines and overbank lines for a stream?
So we're drawing them in, but when you get to the program, you can move them around, right? How are we translating what we draw to what's inside of HEC RAS?
So it's probably, to say you want to move that bank. One of the main things it's doing is generating a good reach length for you, which you don't, you probably don't need to change once you've drawn them in, unless you were to like just be building this from scratch and have your reach lengths like way out here and found out the water only gets like this high, then you might go back and do another iteration of it. But say you want to, say you're looking at this and you're like, I think this is really the channel, I want to change that. You don't need to go back and redo anything on your drawing, because all that's affecting is your Manning's end value. The reach links are generated from the other lines, so you can still make tweaks like that. This is just to really speed up the process of creating the model. Like you could technically do a non-georeference model and not do any of these steps and just go manually figure everything out and stuff, but that would just be, I recommend we never do a non-georeference model unless we're just looking at something so basic like a little straight channel or something. So does that make sense? So like if I change this, it would shift where this in value goes. Maybe that's why I'd want to, like, the only reason this affects anything in the model is because it's got a Manning's in change associated with it. Does that make sense?
So how does that line get into the model?
How does that line, so what we're drawing here, the program is going to take us through steps where we would actually, it's going to use these lines to apply the bank and put it right at that spot right there where it hits
okay.
it. Or not the bank, the bank will be right where this one hits. This is only used to generate reach links. And so it's just going to be right there. And so if I got in the model and said, oh, really, it's over here, I could do that without needing to worry about this file being perfect. Like, it doesn't really matter. If I wanted to change, like say, oh, well, that starts a lower end value, or that starts a higher end value, and this is a lower main channel, but maybe it's really right here. I could do that within the model itself. This is just to get something going for you, basically. And whenever I do, like, say you want to add something to it, and you already have a geometry, it always gives you the options. Like, you've already made some changes to this, you just want to add these sections. It gives you options to just add those sections in without messing up what you've already kind of finalized. Does that make sense to everyone? I think most of y'all probably already knew these parts, the steps of the process. Alrighty, well, that's it for today's session. We'll catch y'all on here tomorrow. Have a good one. We'll see you.
You too.
Thank you.